The following is the solution for Chapter 5, Problem 16. A 3 kilogram object is moving in a plane with its x and y coordinates given by x equals 5t squared minus 1 and y equals 3t cubed plus 2, where x and y are in meters and t is in seconds. Find the magnitude of the net force acting on this object at t equals 2 seconds. We're given the object's mass to be 3 kilograms, as well as the object's position functions in both the x and y direction. We're also given t to be equal to 2 seconds. Since we're trying to find the net force on the object, we can use the equation force equals mass times acceleration. First, we're going to find the acceleration in the x direction by taking the derivative of the position function in the x direction. By doing this, we will get the velocity function in the x direction, and by taking the derivative of this again, we can get the acceleration. So, when we have the position function of 5t squared minus 1, taking the derivative will give us a velocity of 10t, and taking the derivative of that will give us an acceleration of 10. Now we're going to find the acceleration in the y direction by doing the same thing we did previously. So we're going to take the position function of 3t cubed plus 2 and take the derivative of that, giving us the velocity function of 9t squared. Taking the derivative of that will give us the acceleration function in the y direction to be 18t. By plugging t equals 2 seconds into both of the equations we just found, we can find the acceleration in both directions. The acceleration in the x direction comes out to be 10 meters per second squared, and the acceleration in the y direction comes out to be 36 meters per second squared. We can use the acceleration we just found by plugging it into our force equals mass times acceleration formula. By doing this, we'll get the sum of all forces in the x direction to be equal to 3 kilograms times 10 meters per second squared, which comes out to be 30 newtons. We do the same in the y direction, by plugging in our acceleration in the y direction into force equals mass times acceleration. Thus, the sum of all forces in the y direction is equal to 3 kilograms times 36 meters per second squared, which gives us 108 newtons. To find the net force, we're going to use Pythagorean's theorem with both the force in the x direction and the force in the y direction. This means the equation for net force will be equal to the square root of the forces in the x direction squared plus the forces in the y direction squared. By plugging in both of the forces we previously found, we find that the net force is equal to the square root of 30 newtons squared plus 108 newtons squared, thus giving us a total net force of 112 newtons.